Modern web applications need a fast, reliable front door. Nginx is that front door. It is a web server, a reverse proxy, and a load balancer, all in one tool. It was built specifically to solve a problem that broke other servers, handling 10,000 simultaneous connections. This chapter explains what Nginx is and why nearly every serious production stack uses it. Nginx plays three roles. As a web server, it serves websites and static files directly to browsers. As a reverse proxy, it forwards requests to your backend application, Laravel, Node.js, anything. As a load balancer, it distributes traffic across multiple servers. Netflix, Airbnb, GitHub, and WordPress all run Nginx in production. It is one of the most deployed pieces of software on the internet. 3 reasons developers choose Nginx. First, speed. Its event-driven architecture handles thousands of requests simultaneously with low latency. Second, memory. Traditional servers create a new process for every request. Under heavy load, memory explodes. Nginx uses a small fixed set of worker processes. 10,000 connections, same few workers. They use non-blocking I/O. While waiting for one response, they handle thousands more requests simultaneously. Nginx is a web server. It is a reverse proxy. It is a load balancer. It is event-driven. It handles 10,000 or more simultaneous connections with low memory. Netflix, GitHub, and Airbnb use it. Every modern PHP and Node.js production stack has Nginx at the front. Understanding how Nginx works internally explains why it's so fast. One master process, multiple worker processes. Each worker runs an event loop that never blocks. This architecture is what lets a single Nginx server handle tens of thousands of simultaneous connections with minimal resources. Nginx has 2 types of processes. The master process runs as root. It reads the configuration file, binds to ports, and spawns the workers. It never handles connections directly. Its only job is to manage workers. When you reload the config, the master gracefully restarts workers without dropping any active connections. Workers do everything else except connections, read requests, process them, send responses. Each worker runs in a single thread but handles thousands of connections through non-blocking I/O and an event loop. The key difference from traditional servers is non-blocking I/O. A worker receives a request and needs data from the database. Instead of waiting, it registers a callback and immediately moves to the next request. When the database responds, the event loop triggers the callback and the response is sent. No waiting, no blocking. In a traditional blocking model, request 1 arrives, wait for the database, respond, then handle request 2. In Nginx's non-blocking model, request 1 arrives, ask the database, immediately handle requests 2, 3, 4. When the database responds for request 1, send it while continuing to handle new requests. 5 steps every request takes through Nginx. Step 1, browser opens a TCP connection to port 80. Step 2, an Nginx worker accepts the connection and reads the HTTP headers. Step 3, Nginx matches the request URL against location blocks in the config, static file, PHP request, or proxy pass. Step 4, Nginx either serves the static content directly from disk or forwards to PHP FPM, Node.js, or another backend. Step 5, the response returns, Nginx sends it to the browser, the connection stays open for HTTP2. Nginx configuration lives at etc/nginx. The main file is nginx.conf. Individual site configs go in sites available. Each file is one website. To activate a site, create a symlink from sites available into sites enabled and reload. 4 essential commands. systemctl start nginx to start, nginx-s reload to apply config changes without downtime, nginx-t to test for syntax errors, and systemctl status nginx to check if it's running. Always run nginx-t before every reload. Master manages workers. Workers handle connections. The event loop is non-blocking. One worker handles thousands. Location blocks route each request to the right handler.
The config lives in etc/nginx/sites available. Test before reload. Reload without downtime.
Time to put Nginx on a server and configure it. 2 commands to install. 1 file to configure. 4 steps to go live. This chapter covers the complete setup process, from a blank Ubuntu server to a running website with a proper Nginx configuration. Install Nginx with 2 commands. First, sudo apt.update refreshes the package list. Second, sudo apt install Nginx installs and automatically starts the service. Visit your server's IP address in a browser immediately after install. You'll see the Nginx welcome page confirming it is running. 4 service commands to remember. systemctl start to start. systemctl enable to enable on boot. systemctl status to check, and nginx-s reload to apply config changes. A server block is the fundamental unit of Nginx configuration, 1 server block per website. It tells Nginx 5 things: which port to listen on, which domain name this config is for, where the website files are on disk, what the default file is, and how to handle different URL patterns through location blocks. The listen directive takes a port number, 80 for HTTP, 443 for HTTPS. Server.name takes the domain. Root takes the absolute path to the files. Location blocks handle specific URL patterns. Location / handles everything. Location /assets/ handles only that path. Location tilde.php $ is a regex that matches all PHP files. Multiple location blocks in 1 server block let you apply different rules to different request types. Try-files is the directive that makes routing work. It checks, does a file exist at this exact path? Does a directory exist? If neither, fall back to a final option. For Laravel, the fallback is index.php with the query string. This routes all requests through Laravel's router. 4 steps to make a site live. Step 1. Create the config file in sites-available using Nano or any editor. Step 2. Create a symlink from that file into sites enabled. This activates the config. Step 3. Run sudo nginx-t to test for syntax errors. If the test fails, fix the error before continuing. A broken config means the reload will fail and your site goes down. Step 4. Run sudo nginx-s reload to apply the new config without restarting, with 0 downtime. To disable a site, delete the symlink, reload, the config stays safe in sites-available. Apt install Nginx installs it and starts it. The server block configures 1 website, port, domain, root directory. Location blocks route each URL pattern to the right handler. Try-files checks for real files before falling back to the application router. Always run nginx-t before reload. Reload applies changes without downtime. 4 chapters to go.
Nginx has 2 superpowers. First, serving static files faster than almost anything else. Second, forwarding dynamic requests to your backend without the browser ever knowing the backend exists. This chapter covers both, and how to combine them in a single server block for maximum performance. Static files are files that never change per request: CSS, JavaScript, images, fonts, and videos. Nginx reads them directly from disk and sends them to the browser. No PHP execution, no Node.js process, no database query. To serve the assets folder, you point a location block at a root directory. When a request comes in for example.com/assets/style.css, Nginx reads var/www/project/assets/style.css and sends it. Nginx uses the Linux send file system call, 0-copy file serving at kernel level. Add an expires directive to set browser cache headers. Expires 30D tells the browser to cache the file for 30 days. A reverse proxy sits invisibly in front of your application.
The browser talks to Nginx on port 80. Nginx forwards to your app on port 3000 or whatever port it runs on. The browser never knows the app exists. The configuration is just one directive, proxy_pass followed by the backend URL. Proxy pass http:/localhost 3000 forwards every request to your Node.js app. Benefits? Nginx handles SSL so your app doesn't have to. Nginx compresses responses. Nginx rate limits. Your app port is never exposed to the internet. When Nginx forwards a request, your app sees Nginx's IP, 127.0.0.1, not the real client. Proxy_set_header fixes this. Host passes the original domain name. x-real-ip passes the real client IP. x-forwarded-4 passes the full chain of IPs the request passed through. Without these headers, your app cannot log real visitor IPs, cannot geoblock by country, and cannot rate limit per user. Laravel reads x-forwarded-4 automatically when you configure it as a trusted proxy in Trust Proxy's middleware. In a real application, one server block handles both. A location block for /static serves CSS, JS, and images directly from disk with a 30-day cache header, 0 backend load. A location /block with proxy_pass forwards all other requests to the Node.js app. In a typical web application, 70 to 80% of all requests are for static assets. Serving those from Nginx means your Node.js or PHP process only handles real page requests, dramatically less backend load. Static files served from disk via root and location, fastest possible delivery. Expires sets browser cache headers. Proxy_pass forwards requests to any backend. Proxy_set_header passes the real client IP and host. Combine both in one server block. Static assets never hit your app.
Laravel is a PHP framework. Nginx cannot execute PHP directly. PHP FPM is the bridge between them. This chapter covers the exact configuration you need to run Laravel in production, the complete 4-component stack, the complete Nginx config file, and the one security rule that protects your entire application. PHP FPM stands for PHP Fast CGI Process Manager. It is a completely separate service from Nginx. Nginx receives a request for a PHP file, passes it to PHP FPM via a Unix socket. PHP FPM executes the PHP code, returns the HTML output to Nginx, and Nginx sends that back to the browser. Install PHP FPM with apt install PHP 8.2-fpm. After installation, a socket file appears at run/php/php 8.2-fpm.sock. A Unix socket is faster than TCP because it stays within the Linux kernel, no network overhead. 6 key parts: listen 80, accept HTTP connections; server name, which domain; root pointing to the public folder, this is critical for security; index, index.php, the entry file. The first location block with try files routes all non-file requests to index.php. This is what makes Laravel's clean URLs like /users/profile work instead of /index.php $page equals users. The second location block matches all .php files and uses fast CGI pass to send them to the PHP FPM socket. Fast CGI param script file name tells PHP FPM the exact path of the file to execute. Each of the 4 components has exactly one job. Nginx accepts HTTP connections, serves static files, and routes PHP requests to PHP FPM. PHP FPM manages a pool of PHP worker processes and executes PHP scripts. Laravel is the application. Routing, business logic, database queries, blade templates, it lives inside PHP FPM. MySQL stores and retrieves data. It never talks directly to Nginx. Browser talks to Nginx. Nginx talks to PHP FPM. PHP FPM runs Laravel. Laravel queries MySQL. This is the most important security rule in Laravel deployment. The Nginx root directive must point to Laravel's public folder, never the project root. If you set root to var/www/laravel instead of var/www/laravel/public, every file in the project is accessible from the browser. Anyone can visit yoursite.com/.env and see your database password, API keys, and all credentials in plain text. Set root to var/www/laravel/public. Only the public folder is web accessible. Everything above it, .env, app, config, routes, database, is completely hidden. Nginx cannot run PHP. PHP FPM does it via Unix socket. Root must always point to Laravel's public folder. This hides .env and all source code. Try files with index.php fallback routes all requests through Laravel's router. Fast CGI Pass connects Nginx to PHP FPM. 4 components, 4 jobs. Nginx, PHP FPM, Laravel, MySQL.
When one server is no longer enough, Nginx scales horizontally. The upstream block distributes traffic across multiple servers. The proxy cache stores responses so backends handle far fewer requests. This chapter covers both the configuration patterns used by high-traffic production systems to serve millions of users. The upstream block defines a named pool of backend servers. Give the pool a name, backend, app servers, anything. List the server IPs. Then, in the location block, proxy pass uses the pool name instead of a specific IP. Nginx automatically distributes requests across all servers in the pool. By default, it uses round robin. Request 1 goes to server 1, request 2 to server 2, request 3 to server 3, request 4 back to server 1. If one server in the pool goes down, Nginx detects it and stops sending requests to it. The remaining servers absorb the traffic. 3 load balancing algorithms. Round robin, the default, cycles requests evenly across servers. Best when all servers have equal capacity and similar processing times. Least connections, add the least con directive to the upstream block. Nginx sends each new request to whichever server currently has the fewest active connections. Best when requests vary in processing time. IP hash, add IP hash. Nginx hashes the client's IP and always sends that client to the same server. This provides session affinity. The same user always hits the same backend. Useful for apps that store session data locally. Nginx proxy caching stores backend responses on disk. When the same request comes in again, Nginx serves it from disk immediately. The backend never runs. Configuration has 2 parts. First, define a cache zone in the HTTP block with proxy cache path. Set the disk location, directory levels, zone name, and memory size. Second, enable the cache in the location block with proxy cache and set proxy cache valid to control how long responses are kept. A cache hit returns in microseconds. A backend response takes milliseconds or more. For content-heavy sites where the same pages are requested constantly, caching can reduce backend load by 90%. Combine both in one config. Define a cache zone. Define an upstream pool with least con and multiple servers. In the location block, enable proxy cache and proxy pass to the upstream pool. Now every request first checks the cache. If cached, the backend never runs. If not cached, Nginx picks the least busy server, forwards the request, stores the response in cache for next time. A single Nginx instance configured this way can handle 50,000 or more concurrent connections. This is how high-traffic sites serve millions of users from modest infrastructure. Upstream defines the pool of backend servers. Round robin is the default, equal distribution. Least con is smarter for variable workloads. IP hash for session affinity. Proxy cache stores responses on disk. Cache hits never reach the backend. Combine load balancing and caching for maximum performance and resilience. One chapter remains. The final chapter. 3 things to cover. Securing Nginx against common attacks, comparing Nginx with Apache so you can choose intelligently, and the complete production stack that combines everything from this series into one architecture. 7 chapters, 1 tool. Every production backend uses it. Rate limiting is 2 directives. In the HTTP block, limit req-zone defines the tracking zone.
$binary remote ADDR means track by client IP. Zone equals API limit :10M allocates 10 megabytes of shared memory, enough to track around 160,000 unique IPs simultaneously. Rate equals 10R per S sets the limit at 10 requests per second per IP. In the location block, limit REQ applies the zone. Burst equals 20 allows a spike of 20 extra requests before throttling begins. This handles legitimate users clicking quickly without blocking them. Requests over the limit receive HTTP 429, too many requests. This is the standard protection against API abuse and brute force attacks. 2 quick hardening steps. First, server tokens off. Without this, every Nginx response includes the exact version number, server Nginx 1.24.0. Attackers use this to search CVE databases for vulnerabilities specific to that version. One line in the HTTP block removes it entirely. Second, security response headers. Xframe options same origin prevents your site from being embedded in iframes on other domains, stops clickjacking attacks. X content type options no sniff prevents browsers from guessing file types, stops MIME sniffing attacks. XXS protection enables the browser's built-in XXS filter. Referrer policy controls what URL information is sent with cross-site requests. Both are excellent web servers. The difference is architecture and use case. Nginx is event-driven. One worker handles thousands of connections. Apache is process-based, one process per connection. Nginx uses dramatically less memory under load. Nginx serves static files faster. Nginx has no .ht support. Configuration must be done at the server level, which actually makes it faster since it never reads per directory files on every request. Apache has built-in mod PHP. PHP runs inside of Apache. Nginx requires a separate PHP FPM process. Choose Nginx for new production systems, modern frameworks, and containerized environments. Choose Apache for legacy PHP applications that depend on .ht access or shared hosting environments where Apache is already in place. The complete production stack from browser to database. Browser sends an HTTPS request, Nginx receives it, terminates SSL, and decrypts the connection. If the request is for a static file, CSS, JS, images, Nginx serves it directly from disk with cache headers. If it's a dynamic request, Nginx passes it to PHP FPM via the Unix socket. PHP FPM executes the Laravel application, Laravel processes the route, runs business logic, queries MySQL. The response travels back through PHP FPM through Nginx to the browser. Add the upstream block and proxy cache from Chapter 6, and you have a horizontally scalable, cached, rate-limited, secure production architecture. 7 chapters, one complete picture of Nginx. Chapter 1, what Nginx is and why Netflix, GitHub, and Airbnb use it. Chapter 2, master worker architecture and non-blocking I/O. Chapter 3, installation, server blocks, location blocks, and try files. Chapter 4, static file serving and the reverse proxy. Chapter 5, the complete Laravel and PHP FPM configuration and the public folder security rule. Chapter 6, upstream load balancing and proxy caching. Chapter 7, rate limiting, security headers, and the complete production stack. Rate limit your API, hide your server version, serve static files fast, proxy to Laravel, balance the load, cache the response. Nginx does it all.